Hello everyone, Martin here and welcome to this video, which is about my latest project, EpsilonForge, which is all about electromagnetic simulation and how you can leverage open source and cloud computing for cost-effective innovation. Now, I have been doing research in electromagnetic simulation for over a decade and also worked with the industry, with government projects. And the reason that I'm starting this project is that I have always been shocked about how expensive, how broken this industry seems to be when it comes to non-corporate customer because of the absurdly high prices. Commercial electromagnetic software can cost you high 5 digits or even 6-digit figures just to get started, and that will only get you a ridiculous 4-core license. So you can only use 4 compute cores. If you want to use a modern desktop computer with 12 cores, you need to pay up more. And in addition to that, it's not like a perpetual license that will just work forever. You need to pay 20% extra for annual maintenance fees and support. Now, when it comes to support, it makes a lot of sense to want to have support, to have somebody have your back. And some people say paying for this commercial software is not so much about the software, but about the support. Well, that means that there could be, at least in theory, a company that specializes in support, and the software is open source. And well, this will level the field for many individuals or small companies that want to adopt electromagnetic simulation into their innovation workflow, but they simply can't because of the prices. Because if you get started with open source and you buy some support package to help you make it faster, make it easier, then whenever you want to stop paying for support, you can, and you own everything that what you have done. Because another thing that these commercial companies do is they have vendor lock-in techniques. Once you start using their software, you just can't use anything else. You can't take your work easily out of their software, and you're stuck with them. And well, that's how they charge you. I mean, yeah, maybe the support is the main selling point, but they get you with that. They get you with their ease of use. And you're stuck with them, and they are charging you to the nose, and they have irritating licensing policies. So the value that I want to offer is that by leveraging open source tools and cloud computing, you can escape from vendor lock-in, you can enhance your team and scale it as you need. If you're just starting with an R&D department and you just have one CAD drafter or maybe one junior engineer and a CAD drafter, you need some help. You can scale as you need, and you can turn your R&D expenses into investments because you're going to be building for the long term. If you're a company that you're going to be in areas like radio frequency or electrical machines or photonics, and you start building this software, the underlying physics are not going to change, and the software is going to continue to work, and you can run it on your desktop computers, you can run it on a small server that you have, or you can run it on the cloud. That is if you own the software and if you really own your work. If you're stuck with the commercial company, then you just gotta go by their rules. And if they want to charge you to their nose because they have been acquired by a even larger corporation, like what just happened with ANSYS being acquired by Synopsys, I believe. So it's an even larger conglomerate now. Yeah, they might just want to hike prices on you or whatever their top management decides. So, well, this is what I'm starting with. I plan to do lots of things. For example, I have been checking out that if you want to learn simulation from online videos, it's probably really, really hard because the material is super disorganized. There are many open source projects to choose from. You don't know which tools to combine. The workflow is pretty complex when it comes to electromagnetic simulation. Here I broke it down in a few steps. You need to define material properties, boundary conditions, check the simulation type, select the method, model the geometry, parameterize your geometry or use a CAD system, generate a mesh, convergence analysis, post-processing, run parametric sweeps, or perform optimization. It's a very long process, and with open source, the one of the problems is that you need to pick one tool for each of these tasks, or you need a combination of or 2 or 3 tools maybe, and so it's easy to even get lost into what are the possibilities. So I'm gonna be offering video courses, but I don't have them just now. So I'm gonna start with this simple service, which is electromagnetic simulation consulting with open source, where we can just start, discuss with some initial discussion about why you need a model, what kind of problems do you have, what's your expertise about your particular industry, and how we can turn that into equations, relevant material properties, boundary conditions, and solution strategies to build an initial prototype model capturing the essentials of your project. That would be a step one. And then from there, we can have like a collaborative development agreement where you work on your end, I work on my end, and I help you, or I just follow up with you, or, it's flexible. And of course, we want to drive engineering results. In a case that you want me to do everything for you, I have a team right now, and we can do everything for you if you want. But I believe the step one, where you can help you get started, help adopt, pick the different tools, and get an initial prototype model, is going to offer value for a lot of people. And then I can have your back as you make progress. And so I'm also trying to build my own Epsilon Cloud solution, which will have this process streamlined and access to the latest algorithms. And well, I would be putting the hardest to use open source software at your disposal, because there are many different packages. I can go about this on a future video, probably, how to pick these basic open source tools. They go from the easiest to use but harder to configure for other use cases that are not like built in, to those that are really, really powerful and really flexible, but they also become harder to use. So that's the catch there. And well, why EpsilonForge? I discussed already about a little bit about our values, that we want to help make innovation cost efficient. Now, simulation software, that's the purpose why simulation software exists. Because, trying to build prototypes, physical prototypes, and physically testing them is really expensive and really time consuming. And simulation software was invented to replace that. So simulation software is essentially something that it makes sense if it is cost effective. And now commercial companies charging you to the nose pretty much negate all this effect. The entire area loses its whole purpose. So going back to the roots, we want to do simulation to make engineering innovation cost effective. That's our core value, and we're going to help you in many different ways, with video courses, with support, with consulting, eventually with a cloud. But for now, I need to focus on something simple, and I want to get 10, 20 of you get started with the open source electromagnetic simulation. And for that reason, if you want to talk to me, you can come here to my website at EpsilonForge.com and pick some time to talk to me, and we can have a free discovery call of about 30 minutes. You tell me about your project. I tell you about how I would do it with open source tools, and you can go decide if you want to continue on your own, you want to continue working with me or not. If a video call is too high commitment and you want to write me first, you can write at me at info@EpsilonForge.com. So you can click here, and the email address is copied to your clipboard. That was a tiny little thing I did to the website. And anyway, well, feel free to go to EpsilonForge.com. I'm going to be posting some more overviews of the different tools, tutorials, video courses. There's going to be content, so you might want to follow me on my blog or on the YouTube channel that I'm about to get started with. So, well, that was all. See you in the next video.